We have seen functions already defined by graphs, whether it's a broken line graph or a bar graph. Today we're going to look at functions defined by equations. All right, as you see, we've got what we call function notation and arrow notation. It's just a way to assign our specific function. And if you remember, a function is just that relationship, the relationship between your values, whether it's your domain and your range, your x and your y. So how you read this is f of x. So f of x. That's how you read that. This is your function notation. F of x equals x plus 5. Your arrow notation, you can tell the difference because the one has an arrow. All this is pretty much just plug and chug. We give you values for x, which is your domain, and you plug them in to get your range, which is our y values. I like to think of functions as a machine. We'll call this our function machine. Inside my machine is my function x plus 5. Just like a vending machine. You go into there, you drop in 75 cents, you press the combination, say D5, and out comes out a bag of Skittles. It's always going to be a bag of Skittles when you press D5. Say you put 75 cents in and you press, say, C6, and out comes a Snickers. It'll always be that way. Same thing for this. This function is very unique. If the domain is 0, my x value is 0, what is going to happen is I'm going to take my 0, my domain value, and plug it in to my function. And what the machine does, or the function aspect does, is it replaces x with 0, and 0 plus 5 does the math, out comes 5. Then it plugs in 1. You plug in 1. 1 is your now x. 1 plus 5 gives you 6. And then lastly, we plug in 2 to our function. And 2 plus 5, this will give us 7. This is my, you heard it right, your range. Your domain is your x, your range is your y's. And it's unique because no matter how many times I plug in 0 for this equation, I will always get 5. Same thing with 1, I will always get 6. Same thing with 2, I will always get 7. So it's nothing more than taking the values that they give us and plugging them into my equation, or my function. And that's functions defined by equations. Let's look at one more example here. How do you say this? F of x equals 2x squared plus 3. So your domain that they want you to use is 0, 1, and 2. And I'm not just pulling that out of a hat. These are just random numbers. And you will see this on your assignment here tomorrow. So, using what we just discussed, let's take our first value. First x value is 0. So, plug it in. F of 0. X is now going to be 0. So, it's sort of assigning you and telling you this is what x is going to be. So, we come in here. We'll go 2 times 0 squared plus 3. Simplify, do the work. This cancels, just gives us 3. F of 1. Plug in 1 for x. So it comes 2 times 1 squared plus 3. Well, 1 squared is 1. 1 times 2 is 2. And 2 plus 3 is 5. You can check my math later. And lastly, we have 2. F of 2. So 2 times 2 squared plus 3. Well, 2 squared is 4. 4 times 2 is 8. 8 plus 3 is 11. So my range, let me change color here, my range is going to be 3, 5, and 11. And it only works specifically if my x is 0, 1, and 2. All right? And that's it when it comes to functions defined by equations. I'll write this up to the top, but if this was arrow notation, it might look something like this. F, you have a little semicolon, your arrow, and then 2x squared plus 3. And that's it. Make sure you double check your math. It's nothing more. Again, keep in mind, plug and chug.